Hi ladies. In this video, we are going to set up a system of equations, but unlike the other questions where you solved it using algebra, this time you're going to solve it using graphing. So let's see how this works. So let's suppose, now this is a great scenario. Jeremiah and his children went into a bakery and they bought $20 worth of cupcakes and cookies. Very good use of time and money, cupcakes and cookies. Each cupcake costs $5, and each cookie costs $1.25. Now that's a lot of money for cupcakes. He bought 4 times as many cookies as cupcakes. Graph the system of equations to determine the number of cupcakes, x, and the number of cookies, y, that Jeremiah bought. Okay, well that's nice. They define the variables for us. X is number of cupcakes, and y is number of cookies. So we know that he bought $20 worth total. So $20 equals the amount he spent on cupcakes plus the amount he spent on cookies. How much did he spend on cupcakes? Well, $5 times the number that he bought, so 5x. And for cookies, well, they're $1.25, so it's $1.25 times however many he bought, which is y. So that's our first piece of information, the amount that he spent. But 2 variables, we need a second equation to be able to solve it. So we also know that he bought 4 times as many cookies as cupcakes. So whatever he spent on cupcakes, x, multiply that by 4, and that tells you how many cookies he bought. Y equals 4 times x. That's our second equation. Okay, now we have 2 lines and we're going to graph them. So let's graph the easiest one first. Y equals 4x. This is a line in slope-intercept form. The intercept, you can think, this is 4x plus 0. The intercept is 0. So I know 0, 0 must be a point on the line. And then 4x means up 4 over 1. That's my slope, positive 4. Okay, so that's the first line. The second one is not in slope-intercept form. So we can solve for y in order to graph it. One thing that we could do is, well, we could find the y-intercept. That would be really helpful. So remember when we did in class the little cheater method? The y-intercept is the same thing as saying where x equals 0. So what if we plugged in 0 for x, and then we'll get the y-intercept? That would be helpful. So 20 equals 5 times 0 plus 1.25y. So 20 equals 1.25y. Now let's change this into a fraction. This is one scenario where changing it into a fraction actually helps us rather than makes it more complicated. 1.25 is 5/4. It's the same thing as I have 5/4. I have $1.25. Then I can divide by 5/4 on both sides, which is the same thing as multiplying by 4/5. So 5 cancels, leaves me a 4. 16 is my y-intercept. So I know that my line starts here. I just don't know what the slope is, at least not yet. So what's my slope? Well, I guess I do have to put it in slope-intercept form, huh? So I could solve for y by subtracting 5x. Again, I'm going to change this into a fraction because it'll help me divide. And then I'm going to divide both sides by 5/4. So I already know 20 divided by 5/4 is 16. Minus 5 divided by 5/4 is 5 times 4/5. 5's cancel, equals y. So my slope is -4. So there's an x there. Okay, so we could have just done it this way. This was actually, this step was it was helpful, but we ended up having to rewrite it in this form anyway, so we didn't really need to start with this since we did it again this when we put it into slope-intercept form. Okay, intersect 16, slope -4. A -4 slope is going down 4 and over 1. Down 4 over 1, down 4 over 1. Okay, they intersect. Where do they intersect? Looks like 2, 8. What does that answer mean? Oops, 2, 8. Means x equals 2, y equals 8. Well, x is the number of cupcakes. So how much money would we spend? 2 times $5 plus 8 times $1.25. Let's see if that adds up to 20, and then we know we got it right. 10 plus 8 times 125 is the same thing as 8 times 1, 8 plus 8 times 0.25, which is 2. And indeed, this is 20, so I know we have the right answer. 2 cupcakes and 8 cookies. And that's how you solve these. Okay, good luck. Just remember, put it in a form that you know how to graph it, find the intersection, and that is your answer. Good luck, ladies.